Hi guys, in this video we will be discussing about how to solve the molar concentration of an elemental solution from its origin in a ppm unit. Okay, so for number one, what is the molar concentration of a potassium ion solution or K plus that contains 63.3 ppm of K₃FeCN6 with the molar mass 329.3 grams per mole. So, by understanding the problem, we are asked for the molar concentration. So, molar concentration is simply molarity, right? Or mole per liter. Okay, so another thing here, we are asked for the concentration of K plus, but we were given with the concentration in ppm unit with a different chemical compound, which is K₃FeCN6. So this means we should relate K₃FeCN6 with potassium ion. So this involves stoichiometric coefficient, right? Okay, so as usual, when there is a given concentration, let's start with that. Okay, so for solving this, let us remember or note some fundamental conversions from a parts per million unit or ppm. Okay, if you remember from my concentration video problem, I have discussed about ppm, ppt, and ppb as well. In summary, I have discussed that ppm is basically milligram per liter. Okay, and a can be a converted unit for a solution. ppb is microgram per liter and ppt is nanogram per liter. But in this video, we'll be focusing on ppm, which is actually the most common unit used when in terms of comparing from these three. But these three units are also needed to be memorized, okay? Just in this video, we'll be focusing only on ppm, okay? So remember, ppm is milligram per liter. Okay, I'm just gonna put it in the side for you guys to review. Okay, so let's start with the given concentration, which is 63.3 ppm. Okay, 63.3 ppm is the same as 63.3 milligram per liter. Okay, that is K₃FeCN6. Okay, you see here, I just converted or just simply inputted milligram per liter instead of ppm. Okay, that's the same thing, ppm and milligram per liter. Okay, see here. Okay, after that, let us convert this one to grams. Since our goal here is to convert milligram per liter to mole per liter, and we want mole of K plus. Okay, let's see here. 63.3 milligram, and then 1000 milligram is 1 gram, and that's K₃FeCN. Okay, I'm just gonna put here CN6. Okay, now we can use the molar mass in order to obtain the mole, right? Okay, we can cancel milligram and we're left with gram. So let's use the molar mass of K₃FeCN6. So that is 329.3 grams. 1 mole of K₃FeCN6. Okay, good. Now we can cancel the grams and we are left with 1 mole of K₃FeCN6. This time, we can use or we can relate this K₃FeCN6 with the potassium ion through coefficient or stoichiometric coefficient, right? So 1 mole of K₃FeCN6. How many potassium ion are there in 1 mole K₃FeCN6? 3, right? Because we'll be focusing in K only. Okay, so there are 3 K or potassium ion in K₃FeCN6. So this would be 3 mole K plus. Okay, now we can cancel mole K₃FeCN6. So we're left with mole per liter K plus. And we can solve this, and we got 5.77 times 10 to the negative 4 molar. Okay? Molar is the same as mole per liter. Okay? Mole is mole per liter. And this is mole K plus per liter. Okay? So that's it. Okay. So let's practice more. So next question. What is the molar concentration of calcium ions in a solution that contains 85 ppm of calcium chloride with the molar mass 329.3 grams per mole? Okay, it's the same concept, but this time we are given the chemical name, not the chemical compound. So we must determine first what chemical composition is calcium chloride or what its chemical formula, right? So calcium chloride, so we know that it has calcium. Calcium has a 2 plus charge, and chloride has a negative 1 charge. With that, okay, we can cross this out. This is actually the trick for calcium and chloride. So we have the chemical composition of CaCl2. Okay. Usually this is the case. We're given with the name, not the chemical compound or the chemical formula itself, and thus we must determine for ourselves what is its chemical formula. Okay. But in this video, we'll be focusing more on how to solve the molar concentration of an ion. Okay. For the solution, let's start with the ppm concentration given. So we have 85 ppm. Okay, remember, ppm is simply milligram per liter. And this time, milligram per liter of calcium chloride, which is CaCl2. Okay, now let's convert milligram to grams. 1000 milligram is 1 gram. Now we can cancel milligram and we're left with 1 gram. So this is CaCl2. We can use the molar mass here given. So 1 mole of CaCl2 is simply 329.3 grams. Now we can cancel the grams and we're left with mole CaCl2. But we want to get the mole of calcium 2 plus ion. So we need to do stoichiometric coefficient to relate, right? So 1 mole of CaCl2, how many calcium ions are there? So let's focus in Ca. Okay, if we focus on Ca, there is only one Ca. When we focus on Cl2, there are two Cl. But we're asked for the calcium ion, so let's focus on Ca, which is also 1 mole. So 1 mole. So this is simply a 1-to-1 ratio. Then we can cancel 1 mole of CaCl2. Then we are left with mole of Ca2 plus over liter, that which is simply molarity. So to calculating, this is 2.58 times 10 to the negative 4 molar Ca2 plus. Okay, so this is the molarity concentration of calcium ion. Okay, next question. An environmental water sample contains 42.5 ppm of aluminum sulfate or Al2SO4P. with the molar mass 342.15 grams per mole. Calculate the molar concentration of Al3 plus ions in the solution. This time, we are asked to calculate for the molar concentration of an aluminum ion from aluminum sulfate. Okay, you can try this out or simply follow along. So for the solution, let's start with the given concentration, which is in ppm form. And remember, ppm is the same as milligram per liter. Okay, simply equivalent. ppm is milligram per liter. Then convert milligram to grams. Sorry, this is milligrams. 1 gram. And we can cancel milligram. So this is 1 gram of Al2SO4 3. Okay. Oh my god. Okay, let me rewrite this. Okay. So we can cancel milligram. And we're left with gram per liter of Al2SO4. Okay. Now we can use the molar mass given of the aluminum sulfate. So 1 mole of Al2SO4 is simply 342.50. But remember, sometimes the molar mass is not given. You can use your periodic table to calculate for the molar mass. And with that, we can cancel the grams and we're left with 1 mole of Al2SO4 3. This time we are asked to calculate for the concentration of Al3 plus. So we must relate Al3 plus with Al2SO4 3. Okay, so 1 mole of Al2SO4 3. How many aluminum are there? Okay, remember, this 3 plus here is just a charge, okay? If it is above atom, okay? This is a charge, but if it is below, that is how much aluminum are there. So for instance, we have Al2SO4 3 here, and 2 is here below. This implies there are 2 aluminum. But in this case, Al and we have 3 plus above, this entails that it has a 3 plus charge. Okay, so some students get confused from this. Okay, so let's focus on this one, aluminum. So how many mole of Al3 plus are there in aluminum sulfate? So simply focus on aluminum. I have actually discussed this. So it's 2, 2 mole. There are 2 aluminum in aluminum sulfate. Okay? Okay, now we can cancel the mole of aluminum sulfate and we're left with the unit mole aluminum 3 plus over liter. Right? Okay, so we can calculate this and 2.48 times 10 to the negative 4 molar Al3 plus. Okay, so that is the molar concentration of your Al3 plus from the 42.5 ppm aluminum sulfate. Okay, so that's the last question. Thank you for watching. And if you have questions or suggestions of any chemistry question for future video purposes, comment down below. And thank you for watching and goodbye.